So that is something how we can actually feed the data into a database table and all, right? Now today we'll see more on different value types and other things. Now initially, first let us see something like now how to create a primary key normally, right? Primary key is something, yesterday what we have seen is whenever we are, we used to actually feed the data, right? So we used to give whatever used to be an ID part, like it can be auto incremented or you can give random values or something, right? If you want to make sure that the column which is a key, which is a like it can be a business key or a key which represents a row, particular thread ID or particular student record details and all, right? If you want to make them unique and if you want to make them auto incremented and all, right, then first thing what you'll have to do is you'll have to actually make it a primary key so that it can be unique. Now here in my students tables, right, we have ID as a we have taken user ID which can be a key for different details, different records as such, right? Now in order to make this primary, so we have we have to define one attribute called generated value, right? Generated value. Okay, so I have already defined here. You can see either you can give generated value for either your variable declared, or you can give it for the property which is getter of that, right? You can just say generated value is a annotation which you have to use, and by default if you don't give anything, right, it will take the default input of generated value as an auto, right? Or if you want to give any specific sequence how you actually want to do, right, you can actually mention some strategy for a primary key which you have to mention. Now in this strategy, either you can take, there are three different values which you can take. Either you can take auto is something which is a default value if you don't mention anything. Now when you say auto, right, Hibernate will decide what exactly to start up this primary key with, right, and it will actually increment and it will make sure that each and every value inserted will be unique. Or you can go for identity. Identity, as not all the tables supports, all the databases, not tables, all the databases doesn't support this identity, right? So I mean there are few tables which normally support identity, like databases like you have SQL Server, you have SQLite, you have Sybase also supports identity, Oracle supports identity, and few tables like uh, you have a DB2. The identity token is something else actually, right? In that cases you have to make sure that it should support that, right? So we are going to take sequence, so which will actually maintain sequence. It will start from a value and it will auto increment by 1, and it will make sure that each and every ID being inserted is a unique value. Now in this way you can actually go ahead giving a generated value. So if you are giving this, then every time we are actually creating a student object into table, right, you don't have to give the user ID part, because it will auto increment the value and it will insert. Now this was the one primary key thing which yesterday we just wanted to confirm. And next thing is, let's see how we can read the data. Now for reading data, now this is something which is for storing the details, right? Now reading data in the sense how to read something from database, that is what is reading data. Now Hibernate needs a pattern that each and every table will be associated with some key column which will be unique, right? Now the unique identifier, right, we can actually define using your, as I said, your ID value. If you say ID, which means yes, as we have defined the students as an entity class, right, and whatever parameter is mentioned as ID, right, it will take that as a identifier for the record which you are going to fetch. This is the main ID identifier, which is which will actually take as a point of where class identifier. Now how will this will be identified is that, anyways, we are actually mentioning this class as a mapping model class, and whenever we want to fetch the data, we will actually pass details or data of this uh, ID ID parameter. Fine. So let us just see how we can actually get the data. So I've just written the same code here, like how to get the data. Now, even for getting data, again we have to use something called session. First session factory, and then we'll have to use session. Right. Now, session factory will actually build the complete configuration in order to get the connection details and create a connection, right? And then, in order to get the details, right, we have something called session.get. Now, yesterday we have seen something called session.save. This will actually persist the object into database. In order to get the data, we have get. Now, this get contains two different attributes, two different arguments. One is class, and second one is the serializable argument, which is what is the type of class which you want to get as an output, right? So here we know that we are trying to get a student class type, right, which is we have already mapped to the configuration mapping. And second argument is that we are passing something which is of unique identifier. When I pass 101, right, which means it will actually fetch me a student object whose ID user ID is 101, and this will actually give us an object. Now you can actually map this to the students table. You can just say, let's say it's obj is equal to so and so, and you can typecast your students object. Now this is how we normally create, and once you get this, now obviously you can actually get the details of let's say get name. It will give you the name of a student, and in the same way you can get your student ID. Now this is how we retrieve data from database. Now one thing which we have to keep in mind is, see, every time as we are actually creating a simple class with main, right, that's why I just created session factory here, and even during reading data, again I created this. But normally if you create session factory in these many classes, right, every time you interact with database, you should never create session factory these many times, because as of now Hibernate configuration XML may look small, but mapping classes will be so many. For each and every table there will be there'll be one or more model classes which you can write. For some columns maybe you're writing some model classes and some other so in this way you can just imagine that how many model classes mappings will be there, which means whenever you create a session factory, right, when you say build session factory from configuration, right, which means it will take some time to load the complete session factory, and then it will create a session out of it. Now that is the reason why we in real time we will never create session factory like this every time we need. We create instance of session factory once for the complete application until it gets disposed, and then from that session factory we normally get the sessions. Now in real time, how do we do that is, let me just take a common namespace here, package. Let me call com dot some c dot common. Let's say here I'm going to create a class here, which is, let me call it as globals. Now this is my globals class. Now here what I'll do, I'll just create a session factory here. Let's say I'm going to create a session factory as, let me call it as private session factory. Let me call it as lobj. I'm just showing you something which you should use it normally in real time. So here for this session factory we are going to create a getter setter, and we are going to make the getter setter as only get session factory. So what we are going to do, we are going to remove this set, and we should make this as a only read only. Now here you can see the session factory can be only read only here. Now here what we'll do here, before returning this, we'll just check if the LOB session is equal to null. Then we'll create a object here. New, we have configuration dot, you have something called build session factory dot, you have no. configuration dot, we have something called get map. No, what is that we have used here? Configure. Sorry. Dot. You have configure dot. Then you can actually say out that we want a build session fact and just suppress the methods for that. Now here, this will make sure that it will actually create only one object. So in order to even decrease the redundancy of creating global object, right? So we normally make it as a static. So let's make it a static variable and static method. Yeah, Arjuna?
That is build session factory is a deprecated method, right?
No, it is a deprecated method actually. Yeah.
So we can't use it, right?
Yes, I mean we can't use. This is a deprecated method of Hibernate actually. But even now we are using the same build factory to actually get the build factory. Normally you can actually directly use a build session factory here. Direct build session factory. Right. Again, all these are deprecated, but it is not giving any other method to replace this. But normally whenever you actually create any deprecated methods, right, it will give other choice, right? But I don't know, this API doesn't give any of the other choice to other than this build factory method, right?
But my question is like, when it is deprecated, that means we can't use it anymore. Means that function doesn't work, right?
No, it will work. It will work. No, deprecation doesn't mean that. Deprecation mean, see what is deprecation means is like in future releases it may get deleted. So that is deprecation means. It doesn't mean that it is not working, right? You can use that, but only thing is they should give replacement to this thing actually. Now if you just check out any thread dot wait or suspend, right, they'll actually say suspend, and by saying suspend, right, they'll actually say that yes, you can actually use this instead of that, right? But here Hibernate configuration is not giving something else actually, right? It is not saying that. So that is the reason why we are using a direct build, right?
Okay.
Or maybe it is actually looking for something where you have to give some registry. Right? So that's the reason why it has to mention what we can use. But yes, it can be used. No issues on that. Right? Okay. So here we have made a static, variable and static read-only getter for this. So we are checking every time if it is null, then we'll create an object once and we'll return the object factory. Now let us see how we can actually use this getter in case of our Hibernate SAMs. Now let me remove this session factory. Now which means whenever you don't have any session factories and all, right, which means you should never close your session factory. Once you load your session factory, it will actually get loaded once you start your application. That is why if you are making session factory object at as a global, right, every time you change your configuration, which is XML, you should always restart your server. When I say server, which means you have to restart your web server. When you restart a web server, which means your complete Hibernate XML will be reloaded, and whenever XML reloads, right, the complete object, when you actually try to create, right, the complete configuration will be built afresh. Then all the changes whatever you have made will be loaded again to the session factory. Now here what we are going to use is, we are not going to create session factory again. So we'll just say that you have globals dot, we just say get session factory, right, dot get current session. This will actually maintain a single instance of your session. So in the same way in read data, let's remove this session factory here. So this is how we normally create the things. Now here what we are going to do, here we are going to do some globals, which is global here dot, you have session factory dot you get current session or open session. Now once you create current session, right, which means if you have opened the session already, then it will get that session. Or you can use, if it is a brand new, you can always use open session, because anyways we are going to close this session, right? Then you can actually go for open session. That is fine, which means whenever you want, you can actually use your open session, right? But we can't create connection, which is we can't create session open and keep it alive, throughout life, because what happens is every time every time a new connection happens, right? That connection, if it doesn't get closed, right, then it will be a problem. All the connections will get stacked up, and there will be a traffic problem in database. Right? Again, it's a problem again. So here what we are going to is we are going to remove this. So only session which we are creating out of the session factory, right? So this is how we can actually maintain the session factory at one place like this. So this will never allow any other objects to be created. Only once object created, it will stay forever, because every time we are just checking, yeah, whether it is there or not. If it is there, then we are setting it at once, and every time it moves on, it says yes, it is not null, and it will always return the same object factory which gets loaded for the first requests in this Hibernate. Right? So this is how we can actually create a session factory at one place, right? And if you want, see all the maintenance part of the session factory, right? You can actually do here itself, right? So finally, whenever you want to make sure you want to kill the session, factory, yeah, you can actually create that to kill the session factory. Let's say I'm going to create some void. Let's say kill session factory, because we are going to maintain everything at once, and just say session, just say something like try catch, yeah, session factory dot close, right? So at one place you are actually killing, and at one place you are actually instantiating. Now this is how you can actually create your maintenance class of your session factory, right? So yeah, so this is how we can actually maintain some genericness for this, so that you can, while reading or while writing into database, we know that yes, we have a single session factory. Now this is all about how we can actually maintain things of session factories. Now let's move ahead and see one more important thing here called object types. Now here we have created a model class which is student, right? And we have till now we have seen a singleton uh, value types, we call it as, which is either it was a string or an integer or anything. If you make it as a float, the column will be created, or the column which we are going to update or get the detail will be of type float. Now sometimes we can also create an objects in this model class same as the object which we used to create in serialization, right? Like you can actually create internal classes, right? And you can use object references to actually reference different columns in a single model class, right? Now let's take an example of this. So here we have something called user ID and name, right? Let us say the student have got some more properties like scorecard, let's say, right? So here you can actually give scorecard details like what is the grade, right? What are the complete marks and percentage, let's say, right? Let's say there are three different variables which you can define, but that you can actually define in a separate object as such. So here let me create one more class, and this is not a model class which I'm creating. This is something which I'm creating the class for an object. So let me call it as student, uh, let's say records something, right? So this is a simple class now which I'm going to save this for the complete records of students, like what are the rating, what is the grade, what are the marks, right, and all. Now here, so let me just make some parameters here. So string, let me call it as grade of student. Let me create private string or integer rank. You have private uh, let's say float something. I'll just say percentage. Okay, let's say there are three different internal parameters which you have for student records, and let's create getter setter for this. Let me just check this thing. And okay, now we have getter setter for all these three. Now, so let me just close everything here. Let me just close the data configuration and progress. Okay, so let us say we have these students. Now here I have created a class. Now this is a simple class, this is not a model class and all. Now in order to use this class as an object type in my students model class, right, we have to make either a variable which we are creating. Normally how do we create a model? Let's say I'm taking private, let me talk about as LOBJ student records, right, which is of type something called student records, let's say, right. Now this is my variable which I'm creating for student records. Now you can't actually create an object of a class which actually represents three different columns directly in a model class, right? You have to actually make it as an embedded object, or this class as a embeddable class. So embeddable class, you have something called embeddable. You can see either you can make this class embeddable, which means this class I can actually use as a direct object in my model class, which will represent the internal columns of my table. Now when I say internal columns, it will be same, like you can see here it was username and user ID name, right? It will actually continue actually. So how the columns will be formed is, here there will be a grade and there will be a rank and the percentage. But the only difference is that these details I'm actually mentioning as a separate object. Now this object is called as an embedded object, which is a value type, is something which we have seen already, value types, and this is something which is called as a embedded object type. Either you can make a class embeddable, or you can make your variable of this class as embedded, right? So this will actually make the variable that yes, the object whatever I'm creating are nothing but your direct columns of your table. Now for this you can actually make up the getter setters for this. Getter setter is very important. Until unless you have getter setter, your even this Hibernate cannot recognize what exactly is a set, what to set to this object or what to get this from this object. And whenever you are using this in the source class, now as I said, you don't have to give user ID here, right, which is user ID we have already made as a generated, which is a primary key. Now here, so this is my object creation, right? So let me just split this so that we can understand much better way. Now here what I'll do, so this is student object. So in student object I have a direct set name. Now here what I'm going to do, I'm going to create a student records object as LOBJ, let's say student records is equal to new student records, and here I'm going to set something called student records dot set grade, let's say A, and student records dot set, let's say rank, let's say this is integer, right? Let's say 1 first rank, and let's say student dot set percentage let's say this is something which is 96%, 96 dot, let's say 02, as it was a float, right? You can directly give a float with F. Right, so here we have created a student records object, and we have to feed it to the students model class, which is s1 dot set. You can see we created a getter and setter for the object called student records. Now this was my variable, and this is a set of this variable. Now we will be passing this object called LOBJ student records to this, which means it will actually set the complete, it will create a complete object records, and we are setting it as a object for my students model class, where in my student model class I have defined the object here. Now once you define this and once you try to save it, right, now as per our configuration, right, it will actually go step by step. It will create a column, user ID and name, and then it will see that okay, there is an object which is embedded, which means it will go to this class, it will actually create these columns again, it will come back again, and then it will create, no, it will try to insert the data whatever you have done, which means all the columns are 5, 1, 2, and then we have these 3. So this is how we create a embedded objects here. Now in this embedded objects, right, you can do all the things what we have done in our normal Hibernate model class, which means let's say here you have something called direct grade, right, but normally we doesn't define the column name of any table like this, right. Now which means, so you can actually define these columns as the Hibernate columns with annotations. You can just say column here and just call it as name as student underscore grade, right. Now this is acceptable. If you define any annotation in embedded class, right, now instead of taking up this name, right, it will actually take up the column name which you are actually giving up here. Same way you can call column as name, so let's say here you are giving some student right underscore rank, and at the right column it's always better to give a column annotation for each and every parameter you have defined. It's always better. So let's say it is percentage, right. So this is how you can actually mention. Now what happens is whenever you run this program, so here anyways you are actually taking set grade, set rank, and so on, so like, which means you are internally actually populating these values, but this will be automatically mapped to the column name called, this will be the column name, student underscore grade, rank, and percentage. Now this is how you can actually mention the details actually. Fine. Now, so let us say, so this is something which is called as an embedded object, and this is how we can define an embedded class which can be used in a model class as a embedded variable, which will actually create a internal records. Now in this you can actually create any number of columns, any number of parameters you need. Only thing is you have to make sure that for each and every parameter you have a property being created. Normally we call getter setters as properties. These are parameters or variables. For each parameter or variable there will be a property. We call it as get property or set property, right. The properties are very important here, right, to actually map the details internally, right. So now, so if you read the data, right, so reading data will be again same. So whenever you read data for certain ID here, which means it will actually give us the complete object. Now if you go ahead and create obj dot, you have something called get, you can see there will be an object of student records. Just say dot, you have something called get rank. This will actually give you the rank, because the persistence will be completely same. Now as we have seen in our serialization, right, so when we save data, when we actually create an object which is serializable and create one more class, get the object of that class in this object, and create one more nested class and create object in the second class. What happens, there are 3 different levels of classes. Now the third class object is created in second class and the second class object is created in first class, and only rule here is that all the 3 classes are serializable classes. Then what happens is, just go ahead and create any number of internal objects and save it as a buffer form or a serialized form in a file or in a stream, right. So when you actually deserialize the same object, right, then what happens is same buffer will be remapped to the complete object. In the same way, whenever you try to read the data, right, the complete object, the complete pattern of this object will be remapped to the same student's object which you are actually trying to get from database, because each and every mapping will be done for each and every variable actually, because it is converted to the buffer form in database, right. So this is how the embedded object works, right. And if you want to create multiple embedded objects, right? You can go ahead creating any number of objects, classes you want for different things, and you can create any number of records here. Now this is how we normally create an embedded object, right? Now, so one question will be here that if you want to create uh, various objects for same embedded class or embeddable class, then how does it work? Now my statement means that if I have private, let's say, student records of LOBJ, let's say student records 1, let's say, which means, now let's say this record is some old year record. Now I can just say year also, right? Here it's an old year. Or let's say I want to give a record of different type. Now this is again an embedded one, let's say. Now, so in this case you can see that whenever I call this class object, right, it will create these columns, right? Now if I create one more object of the same class, now what happens? It will try to create same columns again, right? Now a single table cannot have two different columns with same name, right? It will actually give you a conflict. Now in this case, what to do here? But this case is valid, guys. Now this case is very much valid. Now you can see these type of things in several ways. Now here the use case here is that, okay, it's a student records class, and I just gave grade, rank, and percentage. Maybe I'm actually using this same class for, let's say, English, right? Maybe in English what is a grade, in English what is a rank, and in part. So let's say I'm going to use the same record for, let's say, mathematics, which means the column name is different, but I'm going to use the same embeddable class here, right? So in that case, so only thing which is getting conflicted is the column name, right? Now, but the pattern of usage will be same as such, right? So in order to come over that, so we can actually override the names of columns here. Now basically whenever we actually use this embeddable class object, right, which means it will actually use the same name which we have defined either in a column, or if you don't give this column annotation, it will go and take the name of the parameter. So that is what we have learned. Now let us see how we can actually override a column name of an embeddable class in our main model class, right? Now here, let us say this record is something which is my mathematics student records, right? Now in order to override any of the column names, now here columns are also called as a variable names or attributes. Now you have something called attribute overrides. If you want to override one attribute, you can directly go for attribute override actually. If you want to go for multiple, then you'll have to go for multiple or overrides annotation, where the syntax is this. Now you can start creating your own overrides here. Now the first attribute override is something. Now you have to mention what is the name of the column you want to override. Let's say I want to override the grade here. Let me take the grade here, and what is that you want to actually give the new name. So new name, you have to take the column. You can see it is a key and a value. What is the column you want to override, and what is the actual column name you want to give. You can give here as an annotation as column, right? And in column you can give a name. And in this column, it's not taking up this column name is equal to, you have something called, let's say this is my maths underscore grade, right? Now this is one, no, this is not the column. We have to give this name is equal to mathematics. Perfect. Now this is one attribute, right? Now this is one attribute which I have actually overridden one column, that grade here. Now whenever you override anything, right, which means now it won't take either the name of attribute or the name of the column which you have defined with the annotation. So rather it will take the overridden column name. Now it will create a new column named math grade for this object, right? So in the same way you can actually override even the other columns. So let's say you have one more attribute override. You have attribute override of name is equal to, now the name is, this variable name should be same, guys. You have to give the actual column name here so that it will actually take up the, sorry, you have column here as @ column, and you have name is equal to, let's say I want to give maths underscore rank. So here we will be delimiting with the column, sorry, comma. And I have one more column to override, which is @ attribute override of, you have name is equal to, now you have third one called percentage, right? And then you have a column is equal to @ column of name is equal to, let's say, maths underscore percentage, right? Now this is how we can override any number of columns you want, so that whenever an object is created for this particular class object, right, now all the columns created for this particular object will be, these are the columns. And now you have one more object, right? Now if I don't override anything, this, for this object it will take the same column names like student, grade, rank and percentage. And if you want to make sure that even here whatever overriding you are doing is not the same as this, right, then you can actually go ahead for the same overriding of this, which is I can do override here, right? Let's say this is something for some science, right? So here let's say now this will actually override the columns again of grade, rank, percentage to science grade, science rank and science percentage with this object. Now usage will be same. Now you can see that I actually took one object. Now this object is my student record object. You can create one more object for second. Now here whenever you create a second type of object, right, now make sure that you are creating a getter setter for the second object too. It's very important. So here I'm selecting this and it will select. Now this is my second object, which is student record 1. Now go ahead here. Now I can create one more object using the same. So here what I'm going to do, let's say this is student record. Now let us say I'm going to give it as maths. Now this is for my maths records I've added. And let's say I'm going to create one more student record called science, right? So I'm going to use the same object science to give write the details. Let's say science is A or A plus, right? Rank is maybe just say 2 something, and let's say this 92.0. And I'm going to add s1 dot set object 1. So this is my second object, and I want to add a science object to this. Now this will actually add this will actually persist the second object with the column names whatever we have overridden here, attribute override we have done. Now these will be the column name which will be created in table, and this will be the records which will be added up, right? Now why I'm actually saying added, I mean created, right, for first time. Now if it is already there, you can just say in your configuration file, you can just say update here, right? This should be in small, or you can keep U capital, or it will take up, actually it will be a cases too, right? And based on that, so if there are existing, it will actually update the columns, and if there is any new column to be added, we drop the old table and create a new. Now this is how you can create embedded objects and override the columns. And for the same embedded class, you can use the same class in different ways. I'm actually using the same embedded class for different usage columns, for maths separate and for science separate and all, right? So in this way you can also create one more embedded class, and that embedded class you can use in this current embeddable class, right? So you can actually go ahead and create any level of classes which are not model classes but embeddable classes. But all the embeddable classes you have to use the final embeddable class object you have to create in your model class. So until unless you use this in a model class, it won't be considered for creating of any columns. Now why do we need, how can we actually call this as a model class? Two things. You have to make this class as an entity class, and second thing is you have to map this for sure here. Until unless you map your model class with the configuration, Hibernate configuration, right? So there will be no use of creating this as a model class. As simple as that, right? Now this is something which is embedded object and embeddable class we can create, and you can actually go ahead creating these things to any number of levels you want, right? So here again, if you want to make any ID or anything as an ID, right, which is like you don't want to make any of these columns as an ID, which I have used here, like generated value and all, right? You can also use all these things even in your uh, embeddable class too. Everything is allowed even in your embeddable. It is nothing but as we have seen something called struts, right? You can create a multiple configuration struts, right? But we have to add on. Now in that multiple struts XMS, right, you can keep any, like you can keep a default namespace with slash. If you remember, default namespace slash in any of the strut XML. You don't have to actually create at the first XML itself. Same way here, you don't have to create your primary key or any ID at a first model file itself. So you can create them wherever you want, right, in embeddable classes. Now the main purpose why we normally use embeddable classes is for the maintenance purpose mainly, right? If you have in a huge application site, you can have a table with at least 50 to 60 or more than 60 columns, right? Now in that case, we can't actually create one model class and define everything. Instead of that, based on some columns will actually mention some business, and in that same table some columns may actually represent some other business, which is a business model, right? Now based on the business model, separate your classes as embeddable classes, create one model class and create the objects of different model embeddable classes. That will actually do. Now that is how in real time you should create a model class, not that create all the columns in the same model classes. If you feel that there will be few classes, like let's take an example of master classes, sorry, master tables, right? Now master tables itself, now master table is something each and every project will have its own master tables, right? Or sometimes we also, when I say master table, right, so what I mean is, let's take an example of some countries, right? Now let's say there are few in one table, the table is only for maintaining the countries list, and that list each and every country have got its own ID, right? So then that is something which is a master table, which contains only certain data, which will always stay, which will grow in row wise, not in column wise, right? So there, yes, you can actually create a model class with ID and country name, right, to get the data and set the data. You can directly use this. But if you go ahead with some other transaction table, then where you're using country code, you're using some other details, right, then obviously you have to go for some embeddable classes and create a single embedded object for that class in a model class. And the model class you have to mention with including namespace in your configuration, so that the Hibernate will understand whenever you create and whenever you want to persist the object into database, right, it will actually understand, yes, this is how the class mapping is done, because you have done a mapping here, right? Now this is something which is called as a different creating or dividing different classes and creating one model class representing all the embedded classes. Now we normally call these things as either a value types if you define a direct variables with the with the properties, or we can call as embedded objects using your embeddable classes.